Assalamualaikum dear students, and our next topic is electrostatic induction, right? So by definition, when a charged object is brought near to a neutral object, the charge distribution in that neutral object changes. This process of change in distribution of charge of the neutral object, right, due to the charged object is called the electrostatic induction. All right, so basically it's not about the transfer of charge right now, it's about the force of attraction or repulsion due to charges when they are brought close to each other. Right now I'm gonna just consider two metallic balls, and I'm gonna bring closer to them a rod. In your book they've mentioned a piece of a rubber strip or something like that. I've taken a rubber rod, right? I have rubbed the rubber rod with a silk cloth so that the negative charge could be resided on the rubber rod, right? So what happens is that when I bring this rubber rod close to these metallic balls, remember that these metallic balls are in contact with each other, they're touching each other, okay? So they can be treated as one object if they are electrically treated as one object because they are in contact with each other, right? So when I brought this rod closer to one of the spheres, what happens is that the negative charges on the rod will try to attract these positive charges, right? Before I brought this rod closer to them, they were all just neutralized rod balls, right? So they were in a neutral state. When I brought this rod closer to these balls, what happens is that these negative charges try to attract positive charges and also repel the negative charges away. All right, so the basic principle is that the positive charges cannot move. Obviously these positive charges are nucleus, and in metals how would a nucleus move, right? A nucleus is a very heavy part of an atom, so basically the nucleus won't move. What happens is that the electrons, the loosely bound electrons of the atom, will be repelled by this rod, and they will travel to the other point of the system. In this system they have two balls, so these electrons will travel to the other point of the first ball, right, to the farthest point, because they will be repelled by this rod. So that's why we say that the positive charges get attracted, although they don't move toward the rod, but they feel the force of attraction, right? They won't move, but they will feel the force of attraction. And electron, as they are very loosely bound to their atoms, they will just leave their atoms and they will rush through the other side of the ball because they will be repelled by the rubber rod. Okay, so what we're gonna do now is that I'm just gonna place the rubber rod right here, but I will just move this ball away from the other one. Okay, so I'm just gonna increase the space between these two balls. All right, what happens is that keeping the rod in place, when I just increase the distance in between these two balls, and I will then, after just increasing this distance between these two balls, I will just remove this rod and see what happens. Here the negative charges will definitely, when there is no rod over here, they won't get repelled any further, and they will just distribute throughout the sphere, and the positive charges also will redistribute throughout the sphere. But you will see that this ball is now negatively charged and this ball is now positively charged. before I brought the rod closer to this one, they were all neutral. But after this process of non-touching, after this non-touching process, okay, just due to the electric forces between them, they one of the charges got repelled, other charges got attracted, and after we just increase the distance between these two balls, they will attain their negative and positive charges. Of course, now the negative charges cannot escape this ball, the positive charges cannot escape this ball. Why? Because there is a space between them. They are not in contact with each other right now. Alright, so that this ball is now negatively charged and this ball is now positively charged. This experiment shows the electrostatic induction. Alright, so in electrostatic induction, we can again just read it out. When a charged object, in this case the rod was a charged object, it was brought near to the, not in touch, not in contact with the wall. It will be brought near to the neutral object and it will disturb the overall distribution of charge. Okay, when the rod wasn't there, the both two balls were in neutral state. Okay, but when we just brought this rod over here, their electrical distribution got changed. In one side we can see the electrons have resided, and to the other side the positive charges have resided. And when we separate these balls, we see that this ball gets negative charge, this ball gets positive charge. Right, now coming to electroscope. Electroscope using the electrostatic induction to detect or test the nature of the charge. Right, so basically the device used to detect and test the nature of course it will test the nature of charge, whether the charge is positive or negative. The device used to detect and test the positive or negative charges is called the electroscope. Right, so I'll tell you how it's work, and I'm gonna share with you some videos also about it, because you will understand much better when you will actually practically see an electroscope. Alright, so it basically consists of a metallic sphere attached with a metallic rod, and at the end of this rod, what do we have? We have a piece of gold or any other metal, a piece of gold or silver or anything. Usually gold is used. This red strip is a gold strip attached with this rod. Alright, not just attached, it's just attached at this point. Alright, the other parts of the strip can move freely. Alright, now what happens when we just bring a similar kind of rod, a negatively charged one? You can also just put on a positive charge over here. I have taken negative charge. Okay, so when we just bring this negatively charged rod over here, what happens is that it will now attract the positive charges over this. I cannot draw actually over brown ball. Okay, so here the positive charges, it will be inside the ball. The positive charges will come to this point. Of course, the negative charges here will be repelled to the other side of this apparatus, of this metal rod, and positive charges will remain at this point, which will face the attraction force by this rod. Okay, so the same thing happens. There we have positive charges closer to the negative charges and negative charges away from the negative charges. Alright, so what happens is that this strip also contains negative charges now, and this rod also has negative charges. So as this strip is very thin and very light, it will bend. It would just like this, it would bend from its original position. Now the final position of the strip is this one. Okay, the one shown in dotted lines. the strip will bend like this. It will bend because of the force of repulsion, because now negative charges reside on the rod as well as the strip. So negative and negative charges will repel each other, and we have a just bent strip over here. And this scale is just used to just measure the angle of, angle at which it is bent, so that they can calculate the amount of charge or the intensity of charge and all that, right? So I have shared another video with you, the link of another video where you can actually see how the electroscope looks in real life, a 3D model of electroscope and how it works. Okay, so good day everyone.